This is day 57 of Camcorder updates every day until the whole world can type at the speed of thought. Today I'm going to show you the production switches for the Masters Forge in preparation for the arrival of the production PCBs tomorrow. It's part of the D2LS Ultra Miniature Snap Action Switch series from Omron, and it's the one with the blue housing as well as the blue button here. It has the lowest actuation force available, which is 0.6 newtons, and the maximum lifespan and longevity available, which is 20 million cycles per switch. This is what it looks like in real life, and they come on this huge reel so that robotic pick-and-place machines can grab them for surface mounting onto the PCB substrate. For scale, here is a standard mechanical keyboard switch, here is a low-profile optical keyboard switch, and here is the snap action switch. Perhaps counterintuitively, this is actually the most expensive of the three. The primary application that you'll find these in the wild is in computer mice, and it's designed to have a very robust spring mechanism on the inside which clearly articulates a press as well as a release to the user with extremely limited travel movement. And if you really break down the fundamental difference in using a keyboard versus using a mouse, I think one of the key aspects of why these switches are designed differently is because on a keyboard, more often than not, you have finger travel before your actuation. And so you move, you register, and then you actuate. Whereas on a mouse, your fingers never break contact, and you want to be ready to actuate at any given moment with a very subtle movement, the absolute minimum travel distance, and have very precise control at your fingertips at all times. So even though Masters Forge and Camcorder 1 are total keyboard and mouse replacements, the whole principle of being able to access all of your inputs without your fingers ever breaking contact with very subtle motions is a lot more akin to what you would find on a mouse than a keyboard, and that's why these switches make a lot more sense here. So a lot of people see the layout, or they hear that it's a three-dimensional switch and they assume, oh, it's like an analog stick. And that, I think, is also another common misconception, because if you look at the finger travel on an analog stick compared to on the Masters Forge, drastically different. And imagine if you were going to try and play a video game on whatever, a game controller, and you're only moving the analog stick like less than 1 millimeter in each direction. There's going to be a lot of noise in that data, and it's going to be really hard to collect meaningful data from the potentiometer here, not to mention that you don't have any good haptic feedback to tell you whenever something is clearly activated versus deactivated like you have on the snap action switches. We did build some Masters Forge prototypes with Hall's Effect sensing modules just to test it out. And I know analog switches are very trendy in the keyboard world right now, but when it comes down to it, there's a reason why in shooting games they map your trigger finger to your mouse. It provides clearer articulation, less effort, less travel distance, and more precise control, bottom line, especially in this application where your fingers never have to break contact with your input device. Thanks for nerding out and talking about switches with me. I can't wait for these PCBs to show up tomorrow. It's gonna be awesome.